Risk management told us what to find and fix. This module shows the actual controls that do it across two halves of the lifecycle, building the system right and then running it right. Picture the lifecycle split down the middle. On the left, development, where risk gets built into a system, in the data and the model. On the right, deployment and use, where that risk actually plays out on real people. The controls in the first half prevent harm, the controls in the second half catch the harm that slips through. You need both halves. And here's the common failure: organizations that build their own AI tend to obsess over the development half and neglect deployment, while organizations that buy their AI skip development entirely and aren't sure what to govern. By the end of this module, you'll operate both, whether you build or buy. We start development with the single highest leverage control, data governance. Remember Module 1, most AI risk originates in the data. So before any training happens, the data passes through a quality gate that checks several things. Provenance, where did this data come from, and do we actually have the rights to use it? Quality and accuracy. Representativeness, does it reflect everyone the system will affect, or just some groups? Consent and a lawful basis. Data minimization. And labeling quality. Get this gate right and you've prevented most downstream harm at the source. Get it wrong, and no amount of clever modeling later will fully save you. This is where the strongest control belongs. As you build, you document, and two formats have become standard. A model card is like a nutrition label for a model: its intended use, its performance, its limitations, how it was evaluated across different groups, and the ethical considerations. A datasheet for a dataset does the same for data: its provenance, composition, how it was collected, the consent behind it, and its recommended uses. Now, people roll their eyes at documentation as bureaucracy, but reframe it: this is how the risk team, the auditor, the regulator, and the next engineer who inherits the system all understand what they're actually holding. Undocumented AI is ungovernable AI. The model card is the paper trail the rest of governance runs on. Now bias mitigation, and this connects straight back to Module 3. You can intervene at 3 points in the pipeline. Pre-processing, fix the data before training, rebalance it, remove proxies for protected traits. In processing, constrain the model during training so fairness is part of what it optimizes for. And post-processing, adjust the outputs or decision thresholds after the fact. But here's the critical reminder: you cannot remove bias in some general sense. There's no debias button. Remember, fairness has multiple incompatible definitions. So first you pick and justify your fairness metric, as Helios had to, and then you mitigate against that chosen, documented target, and measure whether you hit it. Mitigation is always relative to a definition you've committed to in writing. Before anything goes live, it runs a test battery. Accuracy and performance, does it work? Robustness, how does it handle edge cases and adversarial inputs? Fairness across groups, using the metric you chose. Explainability checks. And then something distinct: red teaming. Validation asks, does it work? Red teaming asks the opposite question: how can we deliberately make this fail or misbehave? You actively attack your own system to find its weaknesses before someone else does. For generative AI and for high-risk systems, adversarial red teaming has gone from a nice-to-have to an expectation. In fact, the EU AI Act requires it for the most capable models. Test that it works, and test how it breaks. Remember the AI-specific security threats from Module 2: data poisoning, model theft, adversarial inputs, prompt injection, and supply chain attacks through poison dependencies or pre-trained models. The governance principle for all of these is: defend during development, by design. You build the security in as you build the system. Because bolting security onto an already deployed model is far more expensive and far less effective than designing it in from the start, exactly as we learned in traditional software security. And critically, this is where your AI governance function and your security team have to genuinely collaborate, not work in separate silos. The last development control is where governance becomes automatic: MLOps. MLOps is the engineering practice of running machine learning in production, and you embed governance directly into that pipeline. Version control for the data, the code, and the model, so you can always reproduce exactly what you shipped. Approval gates, so no model gets promoted to production without a sign-off. Change control. And audit logs that record everything. The beauty of this is that the controls stop depending on individuals remembering to do the right thing, they're enforced by the pipeline itself. A model literally cannot reach production without passing through the gate. That's governance that scales, because it's automatic rather than reliant on goodwill. Let's close the development half with Helios. Remember the bias the impact assessment caught women's selection rate at 68% of men's. Helios treats it, it rebalances the training data and applies an in-processing fairness constraint. The result, women's selection rate now sits within the 4/5 threshold, and importantly, overall accuracy held up. Then it documents a model card stating the intended use is screening support only, assisting a human, never autonomously rejecting anyone along with the known limitations. And it logs the whole thing in its MLOps pipeline with sign-off. The bias from Module 8 is now treated, verified, and documented, with the evidence trail ready for audit. The development half is complete. Now the deployment half, and it opens with a reality check. Most organizations don't build their own AI. They buy it, through vendors and APIs. Look at the pie chart, a thin slice built in-house, a huge slice bought in. And that completely changes what governance looks like for most people. You can't inspect a vendor's training data. You can't red team a model you don't have access to. So you govern third-party AI not through code, but through contracts, evidence, and due diligence. For the majority of governance professionals, AI governance is, in practice, largely a procurement problem. That's not a limitation, it's the actual job. So how do you govern AI you bought? Through a procurement due diligence process, before you sign. Here's the checklist. What's the provider-deployer split? What exactly are they responsible for versus you? Can they show conformity and test evidence? Is there a model card and data provenance? For something like a hiring tool, can they show bias audit results? Do they have security attestations, ideally an ISO 42001 certificate? What are their incident and update commitments? Do you have a right to audit them? And crucially, what are the data use terms? Will your data be used to train their model? You push duties up the supply chain, and you get the evidence in writing, in the contract, before deployment, because after you've signed and deployed, your leverage is gone. We've mentioned human oversight several times, now let's define it properly, because it's the control most often faked. The rubber stamp version, a human clicks approve on 200 AI decisions an hour, with no real ability to see why the system decided what it did. That's not oversight, that's laundering an automated decision through a human. Meaningful oversight means the reviewer has the explanation, has genuine authority to overrule the machine, has the time to actually think, and this is key, is measured on catching errors, not on throughput. The enemy here is automation bias, our natural tendency to just trust the computer. The EU AI Act specifically requires oversight to be effective, and effective is a high bar. Remember transparency from Module 3? At deployment it stops being a principle and becomes concrete artifacts. To users, a clear disclosure that they're interacting with AI, and labels on AI-generated content. To the individuals affected by a decision, a meaningful explanation of why the system decided what it did, and a clear route to contest it. For Helios, that means an actual notice to candidates telling them AI is used in screening, giving them a meaningful explanation, and offering an appeal path. Transparency you can't point to isn't transparency. At this stage it has to exist as real notices, real labels, and a real explanation page someone can read. The final stretch of the lifecycle has 3 parts. Monitor, we covered this in Module 8, track performance, drift, bias, and usage continuously. Incident response, you need an AI-specific playbook, because AI fails in AI-specific ways. When a model starts producing harmful or biased outputs, you need a defined sequence: detect, contain, investigate, notify the people who need to know, and remediate. And finally, decommission. Retiring a model safely is itself a governed act. You archive the documentation and logs, handle the data properly, notify users, and manage anything downstream that depended on it. Governance doesn't end at go live. It doesn't even end at shutdown. There's a right way to turn a system off. Helios reaches go live, and its checklist is all green. The recruiters have been trained as meaningful reviewers. They can overrule the tool, and they're measured on whether they catch its mistakes, not on speed. Candidates get a disclosure, an explanation, and an appeal route. There's a monitoring dashboard tracking selection rates by group, so if bias creeps back in, Helios sees it. The incident playbook is ready. And the vendor contract has been updated with audit rights and an explicit term that the vendor will not train its models on Helios's candidate data. Built right and run right. That's the whole lifecycle, genuinely governed, not on paper, but in operation. To recap both halves. Development, data governance first, model cards and datasheets, bias mitigation against a chosen and justified metric, validation plus red teaming, security by design, and MLOps gates that make controls automatic. Deployment, procurement and vendor due diligence, because most AI is bought, meaningful human oversight, real transparency and contestation, ongoing monitoring, an incident playbook, and safe decommissioning. Helios is now built right and run right. Next, in Module 10, we confront the systems that break these classic controls, generative and agentic AI.